write bitstream complete. Okay, and I get this message. So I'm gonna go and open the hardware manager, but I'm not gonna open the target just yet. Okay, I'll just leave it as it is now. Now inside my project folder, I'm gonna look two files. One is called the bit file. It's gonna be somewhere inside these folders. Okay, it's gonna look something like that. Okay, and it's gonna follow the name of your block design wrapper. Okay, so our block design was called design 1 and its wrapper is design 1 wrapper. I'll just copy. I as a practice of my own, I copy the files. Okay, and this is my HWH folder. It follows the name of the block design. So my block design, as I previously mentioned, is design 1. Okay, I copied and I pasted. So something that I generally do for every project, I go in the folder, I put these two, okay, inside the folder like directly, okay, and I keep them. Okay, sometimes I give them some names to figure out when did I create this bit file and this HWH file, in case I do modifications later and they turn out to be not working. Okay. Afterwards, I'm gonna connect to the FPGA. Okay, let me connect on the FPGA and show you. So now I'm inside my Jupyter environment. Okay, I have connected my Pink Z2. Okay, and I will upload my design bit file and HWH files. And what's important here is to have both files given the same name. Okay, so and I have already created a Python notebook, okay, to test out the functionality of our adder. I'll show you. Now that my Jupyter notebook has loaded, okay, and as you can see, as I mentioned, I already have my bit file and HWH file by the name of design_1. Okay, so now in our Python code, first thing we need to do is to load our overlay. Okay, and inside the overlay, we specify our bit file. Okay, and in here we this is a way just to make it easier to reference the XIDMA. Okay, and one thing to note here is this name, okay, follows actually the naming inside Vivado block design. So if I open my block design here, it follows this. So if you change this right here, okay, it's gonna need to be changed in your codes right here. Okay, so in the first block I import everything needed. Okay, in the second block I create a function to just concatenate my two values that I want to add into a single 64-bit integer to be later sent through the DMA. Okay, and I define a function to send and receive, okay, data from memory. Okay, and in here I start creating my data list. Okay, so I just basically add the same number to itself, okay, for the numbers from 0 to 9. Okay, and I allocate 2 buffers in memory. Okay, this is an important step. You need to do it using this allocate. You need to specify the shape, which is basically the size of your data. Okay, so you see here I give it this num data, okay, which is nothing but the length of my list right here, and the type. So my input data for the input buffer, it's 64-bit unsigned integer. Okay, and for my output buffer, okay, it's gonna be 32-bit unsigned integer, and we can change it to signed, okay, if we were gonna send unsigned values. Okay, but that's not um, what we're looking for right now. Okay, and in here I load my list of data into my input buffer. Then I call the function that sends the data I want to add to my adder and receives the outputs back. Okay, and finally I free the buffers. This is something that we need to do, which is to free the memory, okay, from the buffers. Okay, now I run all of it. Okay, so you see here I have a print statement to print the data, okay, my data. Okay, and as we can see, it looks um, uh, like rubbish data, because when we concatenate, okay, it changes the representation in decimal. Okay, but after adding the data, I print out the contents of the output buffer, and as we can see, 0 plus 0 is 0, 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and so on until 9 plus 9 equals 18. Okay, so this is how to accelerate a function using the exi stream. As we were able to see, uh, the most important part is to properly configure the DMA and the processing system, and let Vivado do most of the work using the automate connections pop-up that keeps popping. Okay, and yeah, that's basically it.